Hey everyone, first of all, happy Holi, and let's solve today's daily challenge, that is Koko eating bananas. So, in this question, we have a monkey who loves to eat bananas, right? So, there are n piles of bananas, and the ith pile has piles I of bananas. So, basically, we have this piles array, and it has these are the piles given to us, and we are given the number of bananas in each pile. So, the first pile contains 3 bananas, the second pile contains 6 bananas, and so on. And we are given the guards have gone and will come back in HRs, right? So we are given H, which is 8 here. So basically, when the guards are gone, Coco can eat the bananas, right? So we are being told that the guards are gone for H number of hours. Now, Coco can decide her bananas per eating speed of K, right? And each hour she chooses some pile of bananas and eats K bananas from that pile. Now, if the pile has less than k bananas, she eats all of them instead and will not eat any more bananas during this hour. Right? So let's understand what this line means. So basically, let's say k is 5. We are considering this first test case here. So let's say if k is 5, that is she eats 5 bananas within an hour. But what she does is she chooses some pile. So if she chooses the first pile, she sees that there are only 3 bananas. But she cannot switch to any other pile within this hour, because each hour she has to eat bananas. So if she is at this pile, she can eat 3 bananas, but she will eat only 3 bananas within an hour. She cannot go to this pile and pick 2 more bananas and eat. She has to stay on this pile only. That is basically, in an hour she cannot switch piles, right? So for 1 hour she has to eat some certain number of bananas, even if that is less than k, right? So that will be counted as 1 hour. So that is what this line means. Now Coco likes to eat slowly but still wants to finish eating all the bananas before guards return. What we need to do is we need to return the minimum integer k such that she can eat all the bananas within HRs. So we need to minimize the speed in which she eats, right? So let's see. So what will be the minimum speed in which she eats the bananas, right? So we can say that obviously if the most minimum will be 1 banana an hour, right? So the minimum will be, so minimum speed is 1 banana per hour, right? But okay, so let's see. So we are given some piles. Intuitively, what we will say, if we want to finish eating within HRs, what we will take the maximum element and consider it as a speed, right? So what we will say that if we can finish all the bananas in the pile which has maximum of them within an hour, right? Then we can certainly say that we can finish all the bananas in other piles with that speed only, right? So here, if I consider k is equal to 11, that is because if we need to finish 11 bananas within an hour, our speed will become 11 only. So k will become 11. So if our k is 11, then we can definitely say, right, that all the other piles are less than k, or they might be equal to k. Oh, sorry, they might be equal to the maximum element, right? So we can definitely eat them within 1 hour, right? So intuitively, we can say that if we want to finish within h hours, right, we can consider k to be the maximum element of this array. But what we have to do, we need to minimize this. We need to minimize this value k, right? So let's see. So when we are saying that if we have k is equal to 11, let me clearly write here. Let's do hit and trial and try to get an answer here. Wait a minute. Right. So we are saying, let's say our k is equal to 11. Then what will happen? We will finish this pile in 1 hour, this pile in 1 hour, this pile in 1 hour, this pile in 1 hour. So basically, we will finish all the piles within 4 hours. So but we see we need to minimize k, and we still have 4 more hours left. So we can use them. So what we will do, we will try with k with some less value of k, right? So what we will say k, let's take k to be, let's say we take it as 7. Let's take k as 7. So if k is 7, what will happen is the first pile will be finished within 1 hour, the second pile also within 1 hour, third pile also within 1 hour, but the second pile, the fourth pile, how many hours will we take to complete it? We have 11 bananas. So in the first hour, we will eat 7, Coco will eat 7 bananas. Now 4 bananas will be left. So as we saw, So in the first star, she eats 7 bananas, 4 bananas are left. So she need to finish 4 bananas, and she to finish 4 bananas, she will still take 1 hour, right? So we will be taking 2 hours. Now how many hours are there? These are 5 hours, right? But we are saying, wait, we still have 3 more hours left before the guards return. So let's take k to be even smaller, right? Let's say k is 6 now. If k is 6, we will eat this in 1 hour, 1 hour. But 7, we have 7 bananas in the third pile, right? And she eats 6 bananas in 1 hour, and 1 banana will be left. So this banana she will be eating in the second hour. So basically, we will take 2 hours to eat this banana. The fourth pile will take how many? 6, and 5 bananas will be left, which she will complete in 2 hours. So we'll be having 2 here. So basically, this becomes 6, right? We are saying, okay, we still have 2 more hours. Let's decrease k further, right? Let's say k is 5. Now if k is 5, we will complete this within 1 hour. The second pile will take 2 hours to complete, this also 2 hours, and this pile will take how many hours to complete? 3 hours to complete. Why? Because see, in the first hour she will eat 5 bananas, in the second hour she will eat 5 bananas, and in the third hour she will eat 1 banana, so 3. So let's calculate this. What is this? 1 plus 2 plus 2 plus 3, which is, this is basically 8, right? Now we are saying, okay, well, we have reached 8, but let's see if we can decrease it further, right? Like if we take k is equal to 4, what will we getting? So here 1, here we will be doing 2 hours, within 3 hours, and within 3 hours here. So again, this is 8. So we're saying, okay, this is again 8. Can we decrease it more further, right? If we take 3 now, so we will be taking 1 hour here, 2 hours here, but this will now take 3 hours, and this will take 4 hours. So what is this? This is nothing but 10, right? So we are saying, okay, so here we got the least speed, and with this speed we can finish eating all the bananas within h hours, right? So that means k is equal to 4 is our minimum. So I hope you have understood the question now, right? That what we are doing and how we are doing, right? Now let's try to build a logic, right? Let me remove this quickly. Now what we said was, if we take the maximum element of this array, right, we can definitely say that we can eat within h hours, right? Because see, h will always be greater than or equal to this pile's length, right? So if we want to, eat within h hours, if we take the maximum element of out of this array, then we can definitely eat all the piles within h hours, right? So we are saying that the answer will always be equal to max, or it can be less than maximum element of the array, right? Now, what is the least speed in which Koko can eat? It is 1, right? 1 banana in an hour. So what we have got is a range, right? We know that, okay, so 1 is the minimum speed with which Koko can eat, right? But we know that our minimum can lie, our minimum can be greater than 1, and our minimum can be less than max. So basically, we know that the answer will lie in this particular range only, right? Our answer will be lying within 1 comma maximum element of this array. Now what you will try to do, you will say, okay, now we have understood this. What we will do is, we know that k values will exist between this. Now we will, iterate in this particular array, and for each k value, we will check whether or not a particular case satisfies or not, right? So the approach that you will be going for is O of n square, right? So it will take piles of size you will be iterating in this array, as well as you will be iterating inside of this range also, right? So you will be taking O of n square in the worst case, right? So this will give you TLE. Now let's see. So we have got a range. Now range is always in ascending order. A range is always in ascending order. So we are saying that this is ascending, this is a sorted array, right? So can we apply binary search here? Because we also need to decrease the time complexity. Can we apply binary search? So let's see. So in binary search, what do? We take a mid, right? We take a mid element, and using that mid element, we do some kind of operation, and we try to find out if we can reject a particular half of the array or not. That is left half or the right half, right? So that is what binary search is. So let's see. If we calculate a mid here, right? So this is basically nothing but k, right? So what we will do, we will check for this particular mid if this is a feasible answer or not, right? So we'll be writing a is feasible logic. We'll be writing a is feasible function, which will tell us whether or not this mid is a feasible value or not, right? So now let's see how we will check if it is a feasible value or not. So what we will basically do is, we have taken a speed, right? So we will divide each and every, we will divide each and every element by k, right? And we will just add them. So we will be getting some number of r's with this, right? We will be getting some number of r's. So though if those r's are less than equal to this h, then we can say that is a feasible answer, right? So that is how, so if we can say that the r's that we have calculated using this particular mid, if that is a feasible answer, then definitely all the values greater than this particular mid will also be feasible. So we can say that we can, because we need a minimum value, right? So we can reject the right half. What we will do? We will move towards the left and find even lesser value. So yes, we can apply binary search. So we are doing some operation on mid using this is feasible function. And if this is feasible, if this particular mid is feasible, then we can certainly say that all the values greater than this will also be feasible. But we need a minimum value. So we need to check whether or not a lesser value is there or not. So we can say we can simply move towards the left part of the array because it contains all the values lesser than mid, right? So that is how we have to apply binary search here, right? So I hope you have understood the intuition and the logic to solve the problem, right? Now let's move on to the code part so that things are more clear to you. Now before moving towards the coding part, Newton School is organizing Code Rush March edition, right? So you need to register in this coding contest, right? So if you register in this coding contest, definitely you will be having good problems to solve. Also along with that, you can also receive goodies and you can also get intern opportunities by registering here, right? So I will share the link of the coding contest in the description and you can go and register from there. Now let's move on to the coding part, right? So what we are saying, we are considering a range, right? And in this particular range, we are doing a binary search. So what is that range? That range is from 1 to the maximum element of this particular array, right? So let's take that. So our start is 1 and our end will be the maximum element, right? Our maximum element of the piles array. So how can we get this? Piles dot end. So this is how we will get the maximum element. And let's also take an answer variable here. Answer will be initialized to int max because we need a minimum value. Okay. Now let's write our binary search. So it is simple. Start is less than equal to end. Now what we will do? We will calculate a mid value, right? Let's call it current speed to, understand it better, because mid is what? Speed. So let's say current speed we are calculating. So how will we calculate it? A start plus end minus start by 2. Now, after we have, calculated this mid element, what we will do? We will be writing an is feasible function, which will be a bool function and which will simply tell us if this particular answer is possible or not. So we'll write is feasible and here we'll pass the piles array, the current speed and h, right? If this particular current speed is feasible, then we said that all the values greater than this will also be feasible. So we don't need to find any value towards the right of the array. So we can simply move towards the left of the array. Also, let's store the answer here only. We'll say ans and current speed. Okay. Now also we will move towards the left of the array. So how will we move towards the left of the array? We'll say end is equal to mid minus 1, that is current speed minus 1. Otherwise, If this particular value is not feasible, that means all the values less than this will also be not feasible. So we should move towards the right of the array. That is, the start is equal to current is speed plus 1. Now let's, so after doing this binary search, we will simply return ans because this will be containing our answer, right? Now let's write the logic for the is feasible function. Right. So here what we are passing? We are passing the piles array, current speed and h, right? So let's write that quickly. And we have int current speed and we have int h, right? Now let's see what we will be doing. First of all, let's take the r's, right? R's is equal to 0. Let's initialize r's to 0. And let's iterate inside of the piles array and we will calculate the number of hours, right? That in which we will be finishing all the piles inside of this variable, right? So hours will contain the number of hours in which we can finish this pile with this current speed, right? So let's write that piles dot size and I plus plus, right? So hours plus equal to, what we will do, we'll say piles I divided by current speed. These will be our hours. And also we saw that if we have k is equal to 5 and this is 6, right? So if we get a remainder, we will be needing plus 1 hours, right? So whatever hours we have got here, we need to add 1 if we get a remainder also. So we will also check if dividing if piles modulo current speed is, it has some value, it is not 0, right? If there is a remainder, then what we have to do, we need to, increment hours. We will do this here also, right? And once we have calculated this hours, now how will we check if these number of how will we check if this current speed is feasible or not? We will simply check if these hours that we have calculated, they are less than equal to h, then we can say that the answer is feasible, that we can finish the piles within h hours, right? So we'll simply return that. So we'll simply return hours less than equal to h, right? So if hours are less than equal to h, it will return true, otherwise it will return false. So here we will be receiving it. So here we'll be getting a true or false value. And according to that, if this function returns true value, then that means the answer is feasible and we should store it. Also, we should move towards the left part of the array to check whether or not there exists a lesser value than the current speed, right? And otherwise, if this answer is not feasible, then we have to move towards the right part of the array. So, okay, so that is the whole logic of the problem. And let's quickly run it and see if this works or not. Okay, so all the cases are accepted. So you can see that this is how we have to solve this question. So what we are saying, we are taking a range, right? So what is that range? So obviously the minimum time Koko will take is eating one banana in an hour, right? And what can be the maximum value? The maximum value will be, what will be the maximum value in the range? That will be the maximum element itself, right? So we can say that in this particular range only we will be getting an answer, and we are doing a binary search in this particular range according to this is feasible function.